Hello, good evening, everyone. Thank you all for participating in
Hello,
today's program.
hello,
So
Henry.
you can,
Can you hear me?
Mr. Kingsley, can you please mute your mic for now? Okay, thank you. For those of you in the comment section, I would like you to kindly introduce yourself. Um, where are you watching us live from? Yeah. Your name, if you're a student, kindly indicate in the comment section your school, your department. If you are a professional, um, I would also like you to indicate in the comment section also. Today, this is a one-day class organized by Royal Grand Engineering Trainings. For those of you that are just participating in our trainings for the first time, we are a talent development firm. We carry out engineering trainings, um, both software and industry aligned trainings like process engineering, piping engineering. We carry out trainings like AutoCAD, Protastructure, Aspen High Seas,
Okay, thank you.
ANSYS, Fusion
For those of
360,
you
SolidWorks,
in the
and
comment
all of that.
section,
Okay.
I would like you to kindly introduce yourself, where um,
We have our
AutoCAD,
instructor here,
Protastructure,
Mr. Kingsley, who
Aspen
is
High
ready
Seas.
to take us on today's class. Mr. Kingsley, can you kindly share your screen?
Kindly introduce yourself, where um, we
So
have
for those
our
of you
instructor
joining us,
here,
I would like you to
Mr. Kingsley, who
introduce
is
yourself in the
ready to
comment
take us
section.
on today's class. Mr. Kingsley, can you kindly share your screen? Yourself, where, um,
We would also
for
like
those of
you
you joining us, I
to
would like you to Mr. Kingsley,
like
introduce
this
yourself in the comment
session,
section of today's class.
also
Mr.
share to
Kingsley,
your
can you
colleagues so
kindly
that they
share your
can
screen?
also participate and benefit from what we'll be sharing in today's training.
Would also like
Okay, we can see your screen, sir. Um, okay, you can start, Mr. Kingsley. The floor is yours.
All right, good evening, everyone, and welcome to this training on Protastructure and AutoCAD. So my name is Sude Kenechku Kingsley, and I'm going to be your instructor for today. Okay, so you're all welcome. Okay, so this training is organized by Royal Grant Engineering Trainees. Okay, um, the Royal Grant Engineering Trainees is a institute that is devoted to offering excellent engineering trainings to undergraduates, students, graduates, and even working professionals. Okay, so that is just a tip of the iceberg of what we do here in REnT. Okay, so this training is going to be um, all about knowing how to develop a general arrangement drawing. That is knowing how to prepare a general arrangement drawing um, using AutoCAD, okay? And then getting this GA drawing ready for use in Protastructure for structural designs. That is basically what we are going to be covering. So we have done a lot of lectures and videos about Protastructure, even AutoCAD and all that. So you can always feel free to reach out to the REnT customer support if you want to get access to those trainings as well. Okay, so without wasting much of our time, I'm going to begin immediately. Okay, so yeah, so this is the model that we are going to be using for this illustration. As you can see here, I am using Protastructure, AutoCAD 2024 version. That is the version I'm using for this illustration. But then again, you can always be able to use any version that you want. Okay, so it's just AutoCAD illustration. So any AutoCAD software should be able to run that. Okay, so having said that, let us get on the way. So what you are looking at here is a 5-story duplex. Okay, so this is a design that was prepared specifically for this particular training. Okay, so this is the 3D model of the building. Okay, that you're going to be using for this illustration. So you can see the 3D model over here, and this one as well. Okay, so moving on, this is the plan views, and here we have the ground floor plan. Okay, so this is a ground floor plan, and these are the spaces and the levels of these rooms. Okay, so this is another ground floor plan, but you can see this one just only that it has these grid lines, and that is it. And here is our first floor plan. You can see that, and the balcony and all that, all the spaces in the room. So we are going to try to make this drawing file to be available for you, so that you can be able to practice and repeat whatever we might have done. So this is just an elevation drawing. This is the front view. We have a back view over here. We have a right view of this 5-bedroom duplex, and we have a left view. And then we have 2 section views, section X and section Y. So whenever you get an architectural drawing, so these are the kind of things that you are going to be expecting to get. Okay, you get plan views, elevation views, section views, and plenty more views and details that are going to be required for this design. So I don't have all the architectural drawing views and others. Like you can see, we don't have a side view here, and we also don't have a roof plan, and that is that. But that is not important for now, because what we have here is exactly what we are going to be needing for this illustration. Okay, so we are going to be breaking it down from getting this architectural drawing from the architect, and then how we are now going to transition it and transform it to a general arrangement drawing, okay, that can be used in Protastructure. Okay, so this is 3D model once more, and that is that. So without wasting much of our time, I would like to begin immediately. So the first thing I always like to do is to copy or duplicate this file. Okay, so that when I start working on it, I won't be running into risk of making mistake or altering the original plan and all that. Okay, so just say CO to copy. I'm going to just drag this and copy it up here. Okay, let's just copy it here. Okay, so this is what we have here. Okay, by the way, we are not going to be going all the way slow by slow, trying to explain everything we do here in AutoCAD, because I assume that most of us are already familiar with the use of AutoCAD or the basic AutoCAD tools. Okay, So we are not going to be explaining much of how to use, this software. I'm just going to be going directly and explaining um, what we are doing or what we need to do. Okay. So whenever we have our drawings like this, okay. So I might want to hold on. Let me shift this 3D views a bit. So let's just keep it somewhere here. Okay, so let's zoom into this. So this is a ground floor view, a ground floor plan, and this is also a ground floor plan. Okay, so what I always advise people or advise students whenever they are about to begin a structural design is to first of all study the architectural design and try to understand what is really going on or what is really going on with that plan, the concept, what is inside the mind of this architect when he was drawing that, and what they are kind of trying to bring out. Okay, so understanding the architectural drawing is going to go a very long way to ensuring that you produce a very wonderful design at last. Okay, so here um, we have on this, we have ground floor plan and we have another ground floor plan. Okay, so I don't really need the two of them. So for now, I'm just going to delete this one. Just select that, hit your delete. Okay, so if you look at this now, you're going to notice this is the entrance. Okay, so let's study the plan. The entrance, and then you're going to see a very large open space entering the building. We have the living room area, and this is actually stair hall is actually meant to be at this place. Okay, so we have a very large living room area, and then a passageway. Then we have this dining area and this kitchen area over here. Okay, so and then by the left we have a kind of a home office and then a visitor's toilet and bath. So the dimensions are all attached as well. Then a veranda opens to an exit there. So we have this patio, we have 2 bedrooms at the ground floor. Okay, so we have a laundry as well. Then we at the first floor, okay, following the staircase up, we are going to find a study room closer to the edge of the building, and then a balcony, um, family living room, pantry, balcony, bedroom, 3 additional bedrooms. One of them is a master bedroom, okay, and then a balcony and all that, okay. So we now understand this now. So we can be able to say from what you have understood, this is an open space, okay. The dining is open, the kitchen is open to the living room and all that. So whatever we are doing, we must make sure that we don't create elements or columns that are going to be causing obstruction to the passageways and all that, knowing that this is going to be a very large span. Okay, so moving on from here. So what we are going to do first is to create our layers. If you have used Protastructure before, you are going to notice something very, very important when importing your members to a DXF file. So the columns or your members, your columns, your axes, and all that, they are all imported when they are assigned to a specific layers. Okay, so the layers and the kind of tools that are used to create these elements or these members in the 2D drawing is going to go a long way to determine how good the Protastructure software is going to read that. Okay, so for that now we are going to create column layers, axis layers, and that. Okay, just we are going to create column layers and axis layers for now. So let's just quickly go to our properties dialog. Okay, so let's create a new layer, and for this I'm going to say grids. Okay, for now let's just add a prefix, or let's leave it as grids for now. So I want to change the color of this layer, so I'll choose this color. Let me use a brighter color. Okay, knowing that you are working on a dark background. Okay, so the line weight is going to stay just like so, and then let's create a new one and call this columns. Okay, and then let me change this the layer color. I like red, so I prefer using red. Okay, you can always feel free to use anyone. It's not that important. It's just a color. Okay, so let's choose this. I can go as high as 0.6 or 0.53 for the line width for our columns. Okay, so this is what I need for now. Okay, so let's just close this up. Okay, so we can see this plan now already has dimensions attached to it. I am not going to be using these dimensions, so I just delete them. Okay, so select them, or let's go select similar, so that you can be able to select all of them. And let's hold shift so that you can select this one and leave only this one, and then say delete. Okay, so our dimensions are gone. So I also want to delete these hatches over here. Okay, so for that, now just select one of those hatches, select similar, and then let's hold down on our shift key and deselect these and go delete. Okay, so once we have done that, this is what we are going to get. Okay, so this design, or this architectural design, wasn't done with AutoCAD. If you can notice that, okay, this was actually done using a 3D software like Revit, okay, and all that. Okay, so that is that. Moving on now, we can now start or begin to start adding our axis and then our columns. So the first thing you are going to do is to add axis. So you are going to start by adding axis as random positions anywhere that we feel is going to be more suitable. Later, you are still going to have the option to edit that. That is why this is an arrangement. Okay, you are still going to rearrange all of them and position our axis at the positions where they are going to be most suitable. Okay, opening this up, I want to make our grid layers active, because that is what we are going to be using for our axis. Okay, so I'll just draw a line. I want to place this axis as the center line of this wall over here. Okay, so for that, now I just select this and then draw a line from this point to this point. Hold on a minute. Okay, so nearest. Okay, so let's draw this line. So let's delete this. So let's draw it again. This is going on. Okay, so we have the line here. So, and then we can now start adding our axis. Okay, so to add your axis, just simply click on use construction line. Simply say XL, enter, and then V, enter for our vertical axis. Then locate the midpoint of this line. Okay, so that is going to be the center line of this. So once you have done that, delete this line. Okay, so just make sure you delete every unwanted line so that you don't run into errors while modeling. So we can now copy this line and then start placing at points where we feel is going to be suitable. Later, we are still going to get the option to edit this. Okay, so what I just used is just a simple vertical construction line for now. So we can now start creating our vertical axis at any suitable positions. Okay, so later we are still going to be changing that. Okay, so we have had one here, so let's add one here. Okay, so we can add one here. So let's just locate our walls. I think we are done with the vertical lines. Okay, so maybe let's add one here as well. Okay, so that is fine. Okay, so now we can now simply start adding our horizontal axis. So first of all, let's draw a line just like this all the way down. Then XL for construction line, enter. Then say H for horizontal construction line. And once we have placed one, escape, then delete this one immediately. Okay, so now let's select this CO to copy, and then let's start placing at wall center lines. Okay, so you can place one here, can place one here. Okay, so let's place one here. Okay, so where else do we need? Okay, so we've done that. Let's place additional one here, and let's also place another one here. Okay, we have now succeeded in placing, okay, at all the, okay, so we can place one here, and we can get one of these construction lines, vertical ones, and then we can just take it. Okay, so I'll place one here. Okay, that is fine, that is fine. Okay, so we have now succeeded in placing our construction lines at regions where we feel they are going to be most needed. Okay, so the next thing we can do is to now trim off all these excess construction lines that are running to infinity. For that, now I just use a simple rectangle tool, and then let's select this, draw a rectangle just like this, and go over here. Okay, seems like we have a column here, as you can see in our 3D view. Okay, let's check this 3D view. So we have a column here, and this column is under this balcony. Okay, so this column is the column that's actually carrying the balcony above. Okay, so for that, now we also need a construction line for that as well. So XLB, enter. So let's place at the midpoint of this circle. And then let's get this one as well. Let's add the midpoint of the circle. Okay, so we have done this now. So let's trim off the excess construction lines. Select this, go TR, enter, and then select this, trim this off, trim this off, trim this off. Okay. Oh, I think we made an error there. Okay, so let's trim this off, trim this off. Okay, so press escape key, and then we can now simply delete this. So once we have done that, we are going to get something that looks like this. Okay, so this is actually working out fine for the time being. Okay, so we can now continue. Okay, so I think we need a construction line, a horizontal one at the edge of this wall here. Let's just take this one and then move it over there. Okay, so we have successfully done that now. So moving on, we are now going to start adding our columns at different points or different strategic positions. Okay, so now to do that, now we are now first of all going to begin with a basic column size. Okay, so we are going to start by adding adding our columns with a basic sizing or an initial sizing of column. Okay, so knowing now that this is a duplex, that is a one-story building, so the size of our columns, that the size of the column that we are going to be using or starting with is going to be around 225 by 225 millimeters, knowing that this knowing that the width of this wall is only about 225 millimeters. Okay, so let's go to annotate and let us try to set our dimensions. Okay, so that we can be seeing it very clearly. So let's go modify, and then okay, so let's go 300 millimeters. Let's go text 300. Let's go primary units and then change the precision to 0, and then say okay, set current, and then close. Okay, so the width of this wall is 225 millimeter, as you can see here. So we can start by using a column of 225 by 225 millimeters. Okay, so for that now we are going to go home and then change our layer properties to that of columns, and then let's say LW so that we can make our line width display to be active. Okay, so okay, hold on a bit. Let's set this up. This should be by layer. Okay, so now click REC, enter. We're going to create a rectangle. We are not going to be using lines to form this rectangle. The reason is because Protastructure only recognize polyline elements for our columns. Okay, so now we are going to say D, enter the dimensions 225, 225, enter 225, enter. Okay, then click at the other point. So the reason why we are starting with this is because that is the smallest we can have. Okay, for now. So the initial sizing of your column actually depends on the kind of structure that you are designing for. Okay, the massiveness of the structure. If we are to be designing for a 4-story building, 5-story building, or let me say if you are to be designing for an 8-story building, so your normal engineering mind should be able to tell you that a 225 by 225 millimeters column is not going to be suitable to carry that building. So the minimum size of column that you might be using for that kind of structure should be around 450 by 450 millimeters and all that. But since this is just a simple structure and it is not a massive structure, so we are free to simply begin with this size of column 225 by 225 for now. So although it is always very good, or it's always best to use the smallest size of column as starting, so that when you start performing your analysis and design, you still get the option in Protastructure to be increasing the sizes of your column. That way your building is going to be, or your structural design is going to be more economical. So it's always best to start with the smallest size. Okay, when we are now doing our analysis, we can now be increasing the size gradually. So I'll just move this. I'm going to get the geometric center and then move it to this point. Okay, yeah. So this is what we have now had. So I've now successfully created this first column. Okay, so we can now just simply copy this now, and then start placing it at strategic points where we feel columns are going to be necessary. Okay, so this is an arrangement drawing, which means we still get the option or still have the chance to start editing and rearranging them and placing them where necessary. Okay, this is just to get the initial setting of how it's going to look like. Okay, so we can simply click and place columns at any point we want. Okay, so we can have one here. Okay, and then we can have one here. Okay, so let's add one here. Let's add one here, and let's add one here. Okay, so I'm going to try to be faster. Okay, let's add one here, and let's add one here. Okay, so we can add one here as well, and then let's add one here. Let's add one here. Okay. So that is good. So we can add one here. Can also add another one here, and we can add one here, and then we can also add one here. Okay, so this is fine. So we can add one here, and I think this is good for now. Okay, so let's add one more here. Okay, so we are still going to be editing all this when the time comes. Okay, so we can also add one here, and okay, so let's leave it like this for now. Okay, so but then again we still need to add this circular column for this. Okay, so this rectangular line is just representing the base of the column, okay, of this circular column. So for that, now we are going to use the circle tool. Just click C for circle, get the center point, and then click at this. Okay, so this is going to be the column for this as well. Okay, so having done that, now The next thing we are going to do is that we are going to now start um, shifting our columns and then making sure that our column distances between them are very, very accurate. Okay, so we need to maintain a maximum distance between columns of 6 meters. Okay, knowing that this is actually a small structure, so we need to maintain a maximum distance between columns of 6 meters. Okay, so if I'm designing for an 8-story building, because it depends on the kind of structure. So if I'm designing for an 8-story building, I will need to maintain a minimum distance between columns of about 6 meters. Okay, a minimum distance, knowing that that kind of building is going to be sitting on a foundation like um a pile foundation. Okay, so this pile foundation usually have pile caps. Okay, if they are close together, if they are too close together, their pile caps are going to be interfering or intercepting with each other, which is not usually very, very good. Okay, so but for this now, this building is going to be sitting on a pile foundation. It's just a one-story building, a duplex. Okay, so for that now, we are just going to be maintaining a minimum distance between column of 6 meters. Okay, and then a maximum distance of 6 meters and a minimum of about 1.5 meters. Okay, so for that now we are going to take a measurement of this distance here. Okay, so let's take from this axis to this axis. Okay, so the distance or the distance between these columns. Okay, that's not the distance. So let's go from here. Let's change this properties for our grids, for our dimensions rather. So let us choose any one of these. Okay, so I can use the dot dimensions for our grids. Okay, so let's go from here to here now, and the distance between that is 4,300 millimeters. Okay, so it's actually less than 5 meters, which is very good. Okay, so we can continue to this place now. Okay, the distance between these columns is 3,225 millimeters. Okay, which is nice. So we can just simply delete it. Okay, we can continue adding our dimensions. Okay, so let's go from here to here now, and we have 225 by 2, we have 2,025 2,225 millimeters, and here we have the same thing. Okay, so the lesser the number of columns that we are getting, the more economical our building is going to be. So for that now, I just need to check the entire span or the total distance of these two span. Okay, knowing that these spans 2,225 millimeters are actually very small. Okay, so the distance is 4,450 millimeters. Okay, so for that now, I just choose to delete this column. Okay, so let me just delete this column just like so. Okay, so we are going to have only two columns for here now. Okay, and then again, we are going to have one column. Okay, so the distance between these two columns here, 1,900. Okay, so and the distance between this column from here to here is 3,825. Okay, we might want to expand it a little bit so that it's going to be most suitable for this. Okay, so let's take the distance from this column, from this axis to this axis. Okay, it's about 2,025, and the distance from this axis here to this axis here is 3,725. Okay, so making this beam to be smaller means that making this beam, the length of this beam to be smaller, means that the beam is going to be less heavier. Okay, so I want to shift this column from this place now. Just click on this grid axis intersection to this one now. Okay, so I think this is the most suitable way to do this for me. Okay, so a quick information. How you perform your general arrangement drawing solely depends on you as the structural designer. There is no particular way of performing a general arrangement drawing or adding your columns where you want them to be. It solely depends on you as the engineer. if I give this drawing to someone else, another structural engineer, there is every tendency that is going to come out with a totally different general arrangement plan. Okay, so it solely depends on you as the engineer. You are always free to add your columns wherever you want them to be. Okay, so moving on now, we have now added these columns and we have also added this one. Okay, so we can check the distance between these two columns here. Okay, this is 1,750 millimeters. Okay, and the distance from this one to this one here is 3075. So let me check the distance from this column, okay, to the one at the extreme. Okay, so this is 4825. Okay, so that is actually very long. Okay, that's not the one. Okay, so let's go from here now to here now. So this is C050. Okay, so for that now I will need to delete this column down. Let's delete this column. Okay, so that the distance between this column and this one is going to be 4,300 and the other one is going to be 1,750. Okay, that's very fine. So we can leave this just like so. Okay, so we are also going to leave this. This looks very suitable. Okay, so we can leave this one here now. Okay, so let's start going from this side. Let's check the distance between these columns. Okay, from this one to this one, 4,300, and let's add one here. Okay, let's do that again. So the distance here is 1750 by 4,300. Okay, so this is actually very accurate. It's the same with the one above here. Okay, so that's very fine. We have just finished placing our columns. Okay, so this column can be here and this one can be here. Okay, so we just need to leave this column at this axis intersection. Okay, and that is that for now. Okay, so the next thing now, you need to do some adjustments here. So as you can see now, these two columns are not well spaced apart. The distance between them is just 1,400 millimeters. Okay, so let's check the distance from this column to this column. Let's be sure that it didn't exceed 6 meters, and it's only about 3.425 millimeters, 3.425 meters. So for that now, I just need to delete this column. And then let's get rid of these dimension lines. Okay, so this is what we have now. Okay, so then this area around this panel, we are going to leave this as so just for now. Okay, so when we go into our beam paneling, so we can now be able to adjust it, how we are going to leave this living room, or how you are going to, what you are going to do about this. Okay, so that is that now. So for that now, after placing your columns and your axis, the next thing that you need to do is what we call superimposing. Superimposing is just making sure that the columns that you have placed at the ground floor level are not intersecting spaces at the floor above it. Okay, so we are just going to perform what is called superimposing. Okay, so we are going to make sure that these columns that you have placed here are not interfering with the different spaces that we have here. As you can see now, the plan is not typical. Okay, the two plans are not the same. Okay, so we are going to perform this superimposing right now. So to do that now, you simply need to select one of the columns and then right click and then go select similar, so that you can be able to select all the columns. Right click, select similar. Okay, so let's select one of the rectangular columns. Go select similar. Okay, so for this now, let's select this one as well. We are going to copy this column and then place it at this first floor. Okay, so when we place it now, we can be able to see where the columns is leading. Okay, so we are going to choose a base point. Let's go CO, enter for copy. Then let's choose the base point. So the base point, the most stable base point that you can choose is the staircase area, because the staircase area doesn't usually change. But if you say, okay, I want to choose this base point at this edge, if you go to the first floor, there is every tendency that is not going to be the same because it's not typical. So I usually prefer to choose a base point from the staircase area, because the staircase area does not change. So let's copy this and then place it at this position right here. Okay, go escape, and then this is what we have. So let us just simply watch this design and look at the places and look at their placement and be sure that be sure and know which of them is intercepting with any space. Okay, luckily we don't have anyone intercepting with any spaces or any element, except for this one. Okay, so this is actually intercepting through this door. Okay, so it's going to be causing forcing this door to either shift to the left or right, and this door is actually leading to direct to the master bedroom. Okay, looking at this design now, you're going to notice something. This door was actually pre-designed to be at this particular position, open up at this particular position, because a space is meant to be here around this place. So we cannot shift this door up, or we cannot shift it down. Okay, so for that now we are going to know what we are going to do about it. Okay, so we are going to treat it right now. So if we shift this column, let's go CO. If we shift this column from here and bring it somewhere around this place, okay, so let's take this base point. Okay, so let's delete this. Okay, so where is this now going to be positioned in this ground floor? Okay, that is what we are all about. Okay, so let's select this. Let's change the color of this particular column. Let's go properties, and then let's change the color, and let me use this green color, lemon color. Okay, so let's select it, go CO, and then let's go from our base point to superimpose it on our ground floor. Okay, so let's see where it is now. Okay, so this column now is now intersecting our kitchen and the space between the kitchen and the dining area, which is not very suitable. Okay, so this position where this red one is the most suitable position for this column at the ground floor. So for that now, what we can do is to push this column upwards. Okay, so if this column starts from the ground floor, we can just terminate this column. Okay, so that is the best thing we can do. We can terminate this column at the ground floor, after the ground floor, and then start up another column at a different location, maybe around this location right here. Okay, so for that now, let me move this column, enter. Let's move this column from this place now to this place. Okay, so now we can now simply delete this column. Okay, so since we are terminating this column at the ground floor, so this column is going to start from foundation and go through the ground floor, and then we terminate this column here, and then this column now is going to start or begin from that first floor and then go all the way to the roof. Okay, so for that now we need to indicate that, so that we don't make a modeling mistake when we now start in Protastructure. Okay, so just simply select this column, and then let's change the color of this column. So I can use this color. Okay, let me use magenta, this magenta color. Okay, so whenever we see this plan now, we can be able to say that this column is terminating. Okay, so any column that we label with this color, okay, that we change the color to this, we can know that this column is actually terminating at this position. Okay, for this now we can simply change this color, the color of this column, indicating that this column is starting from the first floor to the roof. Okay, so you can leave it as green, or let me change it to cyan, this cyan color. Okay, so this is nice for now. This is very good. Okay, so for this now we can now continue checking our columns and their positions. Okay, so knowing that these columns are now going to the roof, and the roof is not as heavy as the first floor. Okay, so the columns here the columns at the ground floor, or your members, your column beams and slabs at this position are going to be carrying your columns and beams at the ground floor will be carrying your beams, will be carrying your slab at the first floor level. So the columns here will be carrying this first floor level, and the columns at this first floor level will be carrying your roof loads. Okay, so that is understood. So the columns here will be carrying this first floor, and the columns here will be carrying the roof. So knowing that these columns are going to be carrying the roof, so the roof is not as much as heavy as the floors. Okay, so what we can do is to terminate one or two columns. Okay, so we can reduce the number of columns that are coming up here. So that way the structure is going to be more economical. Okay, so for that now we will simply need to can terminate this one here. Okay, before we do that, let us check the distance between these columns. Okay, so let's go from center point of this to the center point of this. Okay, so this is about 6.5 meters. Okay, 6,050 millimeters. Okay, since this is carrying the roof, I might want to take I might want to go all the way, and it's only about 6 meters. Okay, so we can simply remove this column. Okay, at the first floor level. So which means we are terminating this column after this ground floor. Okay, so select this down, and then let's go properties, and then change this to this magenta color. Okay, so I think this our grid lines is interfering with the this magenta color. So let's change the color for our grids. So let's go something lighter. Okay, so let's find the yellow color. Okay, so okay, yeah, okay, yeah, I think this is more comfortable to look at. Okay, just like so. Okay, so you can see now that we now have two columns that we are going to be terminating here. So we have this column here, and then we have this column here. We are going to be terminating both of them. Okay, so having done this now, next thing that we need to do is to now start performing adding our beams. Okay, so performing what we call paneling. Okay, we are going to start paneling our design. Okay, our plan. Okay, so we are going to be arranging our beams and then our plans. Okay, so for that now I will now need to be deleting most of these furniture elements over here. Okay, because they are not going to be very useful. Okay, so to do that now, we simply first of all lock our columns, and then our columns and grids, so that we don't mistakenly delete or select them. Okay, so let's delete all these label elements, text labels. Okay, so let's delete this. Okay, so we can simply call this place a panel. This region here, this region, we can call this a panel. So we can also collapse this wall. Okay, so this wall is not that useful. You can simply just collapse it. Okay, and then delete that door. So this is going to be our first panel over here. Okay, so let us stretch this beam over here. Press EX to extend. Let's extend this beam. And then let's extend this one. So this is going to form our beam. Okay. So let's delete this door as well. Okay, so this region right here is going to be our first panel. Okay, so there are some basic rules that you must need to keep in mind while performing your paneling. So number one is that your panel or your panel area must not exceed 30,000 millimeters square. Okay, that is the length times width of your panel. It must not exceed 30,000 30 meters squared. That is 30,000 millimeters squared. Okay, so for that now we need to check the panel, the size of this one. Okay, the panel area. So this is 4,300 millimeters, and then let us also check the distance from here to here. Okay, so this is 3725. Okay, let us open our calculator to, and let's go 4,300 millimeters multiplied by 3725. Okay, it is 16,000 millimeters squared, which is less than 30 meters squared. Okay, so for this now, this simply means that this panel is okay to be just like this. Assuming this was higher than 30,000 than 30 meters squared, what I can simply do is to just run a beam at the middle. Just create a beam, just draw a beam. Just draw a beam here, just add another beam from the top to this place here. Okay, so but since this is less than 30 meters squared, so which means that this is suitable. Okay, so for that now let us delete this as well, and then let's go to our annotate tab, and then let's label this as our first panel. Okay, let's select a multi-line text, and let's go P1, capital letter P1, which simply means panel 1. So let's select this and change the size of it. So I can go 450. Say okay. So I can change the color of the text. Okay, so I can use any color. Okay, so let me use this one for now. Okay, so this is our panel 1. Okay, so this is panel 1. So let's select this now. Enter to move it, and then let's move it to the middle. So this is our first panel over here. Okay, so this is an empty space right here, but above it now there is a balcony. Okay, over here. So we are going to call this balcony is also going to be modeled. Okay, so let's go CO to move to copy rather. So let's copy from our base points and then place here. Okay, so let's see where it is at. Okay, so this is where that this is where the slab edge stopped. Okay, so this is the railings, and here is where we have slab edge. Okay, so for that now I am going to delete these furniture elements. So let's delete this, and let's delete this text symbol. Okay, so let's select this CO and move this one over here and call this panel 2. Okay, so always feel free to type something on the chat box. Okay, if you're not understanding anything, okay, I can always just save your questions. We are going to have some minutes for questions. Okay, so this region here, this panel from here now to this place is going to be our second panel too. Okay, for that now I will just need to select this and then MA to match properties, and then change the slab edge line so that it can look like this. Okay, so this is panel 2. Okay, for the following panel you can delete this. Okay, and let us also delete the walls, the doors rather, and let's check this just like this. Okay, so this is going to be our panel 3. Okay, so let's extend this. Okay, so let's copy this immediately. So this is panel 3. Okay, so we are going to delete these ones as well. The bath, the wash and basins, and the shower, the doors, and the toilet seats. Okay, so we can extend this over here. So for this now, let's copy this and place it here. So this is going to be one panel and this is going to be one panel. Okay. So let's change this to P4, which is panel 4. Let's change this to panel 5. Okay. So this beam is going to be going from this column to this column now. This beam will go from this column to this column. So this beam now, we have to go from this panel now is going to be bounded by a beam that will be resting on this particular beam. So this beam here is going to go from this beam to this beam, and then this beam is going to be dividing them, going from this beam to this beam. Okay, so that is that. So for this now, we need to add another panel here. Okay, so let's select this, delete the furniture element, delete the doors, and we are going to have something that looks like this. So let's extend this to cover up the door spaces. Okay, so we are going to have this. Let's extend this as well. Let's extend this. Okay, so let's copy one of these. Okay, so this one is panel 5. So this one should be panel 6. Okay, so you can see how we are going on with this gradually. Okay, so coming here now, so we can choose to collapse this wall. This is not a structural wall, it's not a load bearing wall, so you can simply collapse it. Okay, so let's go from this place. Let's delete all the furniture elements on this kitchen. Okay, so let us extend on this one. Okay, so this is going to be our 7th panel. Let's go CO. Okay, so this is the 7th panel now. So always bear in mind that how you do your paneling, or how you, so I believe that we are all following, and please, if you have any question, please save your question. We are going to have a time for that. Okay, so how you do your paneling solely depends on you as a structural designer. Okay, so whatever you do solely depends on you. You can choose to panel it in a different way. For instance, now you can choose to run a beam across this place now. Okay, so but before we do that, let us check the size of this panel. So because this is looking too big, so if it is more than, okay, so if it is more than 30 meters squared, so we now have to change. Okay, this is 6,000, about 6,000 millimeters by 3,000 millimeters. Okay, so I think this is good for now. Okay, so let us delete this. And then for the dining area now, okay, so we are going to notice something very disturbing, that this panel is becoming already too large, and our beams are going to be going up too long. Okay, so there is a thumb rule that you need to keep in mind whenever you are performing, whenever you are doing your general arrangements. So none of the beams should be longer than 6 meters. Okay, so this beam now, none of them is longer than 6 meters for now. Okay, so none of your beams should be longer than 6 meters. So that should be the maximum length of beams to be used in this kind of structure per se. Okay, this is already measuring 7,004 by 7,200 millimeters, and that is way too much. That is, if when you do the math, it's going to be giving around 49 meters squared. Okay, well, this is 7 and this is 7. Okay, so it is already more than 30 meters squared. So what you can simply do is to run a beam across this place to break up the panel. But then if we do that, our beam, the length of our beam is going to be exceeding 6 meters, because this is already 7 point something meters. So if we run a beam here, it's going to be too long, and it's going to fail due to deflection. Okay, so what we can do is to add a column at a point to be able to break up the beam and also break the slab at the same time. Okay, so to do that now, we are just going to select one of the columns. So let's turn one of them on. Okay, so let's select this column. Let's copy it from here. Then let's position it. Where should we position? Okay, we can put this. We can choose to put this here. Okay, so this is very nice. We will still have some space left between this column and then and this about 800 millimeters. Okay, which is actually fine for someone to be able to pass through. Okay, so this is not actually that bad to have this column around this place. Okay, so having done that, now what you can do, you can now start paneling that. So let us delete all these furniture elements here. Okay, so I think we mistakenly deleted our column. Okay, let's go CO. Okay, so let's log this. Okay, okay, so we have locked our column back to how it was. So let us now simply extend these beams here. Okay, so let's select this, go EX, extend. Okay, so we have now extended this. Let's extend this as well, EX, extend. Okay, so let's extend this one all the way down. Okay, so this is what we have. Okay, so it looks like this is not straight. So let's go Ctrl Z. Let's undo that. Okay, so let's extend that manually. Okay, so let's continue extending. Let's extend this all the way down. Okay, so for this column now, we can see we have two axes here that are very, very close to each other. So I would like to move this here. Let's go CO or M. Okay, so let's turn this on. Let us move this from here to this place now. Okay, so let us also turn our grids on. So I want to delete this grid and we can finally get rid of this. So this is actually not a structural wall. It didn't go all the way. It's actually stopped at the balcony region. Okay, so you can see from our 3D view that wall um didn't go all the way up. Then let's know whether you can see it from. Okay, we can see it very clearly. Okay, because it's in white color. Okay, so that's by the way. So this wall here actually stopped somewhere around under this balcony. Okay, so we are going to leave this just like so. So let us now level this. CO, enter. Keep one here, one here, one here, and then one here. Okay, so let's change this to, this is panel 7 and this one will be panel 8. This will be panel 9. Okay, let's move this to the middle. Panel 9, and this will be 10. This will be 11. Okay, so at this region here, we have a kind, this is a veranda at the ground floor level. Okay, so we can see from this veranda is what we are looking at here. Okay, and then we have a balcony above around this region here. Okay, so we are going to get the dimensions of that balcony from this place. You can see now this balcony is actually taller than I mean it's actually lengthier than the other one below it. Okay, so for that now I just need to copy this, go CO, enter, and then let's take the reference from this column. Okay, and then let's place here. Okay, so with this now we can now simply delete this. This is not going to be useful. Okay, so this is going to function as our slab edge line, this line here. Okay, this is going to be our slab edge line. Okay, so let's just select this and delete this, and then we can have only this. Okay, so this is going to be our slab edge line. We are going to model it as a slab edge line. We are not going to be adding a beam around this place, because looking at what we have in our architectural drawing, there's nothing like a beam. There is nothing like a beam around this place. Okay, so and then we have a wall that started from this place. Okay, so that is exactly what you are going to be doing. Okay, so although this is going to be a very lengthy cantilever, so about 1,850 meters length of a cantilever beam. Okay, that is going to be of a cantilever slab. Okay, okay, so it's actually very possible to be modeled and designed. Okay, so for this now I'm just going to take this CO, enter, and then this is going to be our 12th panel. Okay, let's go P12. Okay, so let's delete this panel 12, and then for this stair hall, so let's delete this label. So this, we are going to be creating a void around this staircase region. Okay, so that is going to be telling us that this is actually a void. Okay, so let's draw a line just like so, a diagonal line, and then let's draw another one from this place now to this place. Okay, so we can take the property of this and let us match properties with this one. Okay, so this is very good. So this is going to be the void. Okay, so we can actually label that if you want. So let me just use this to label it. Let's go void, so we don't forget, and let us copy this or move rather. Okay, so this is going to be our void space. Okay, so additionally we have a kind of a cantilever slab around this place. Okay, so looking at this design now, you're going to notice that this this slab, this balcony actually extended past this slab, this column points. Okay, so for that now we are just going to simply copy this so that we can be able to note the exact points. So let's copy from this place now to this place. Okay, so that is going to be the edge, the slab edge. Okay, so for that now let's go F for fillet. Let's fillet this one. Okay, so this is exactly how this is going to be looking. Okay, so we're going to be having a cantilever here. This is going to be another panel. Okay, so the last panel we did was 12. So let's go CO, and then let's copy this. This is going to be panel 13. Let's just leave it outside there. Okay, so this is actually very good. So a beam is going to cross here, and then a cantilever slab is going to project out to this place now. Okay, so this is very good for now, and then let's continue doing our paneling. Okay, so there is a balcony here upstairs. This balcony is actually okay, so let's check. Let's go and check. So this balcony now, let's select this, go CO. Okay, so let me copy from this column as a base point. Let's paste here. Okay, so this is very good. You can delete this one here, Then we can match properties with this one. Okay, it appears it's not matching, but you can still use that as a base point. Okay, so for this now, let us select this CO, and then let's paste this here. So this is going to be panel 14. Okay, so for this home office, we can delete this home office area. So let us delete the visitors toilet and bedroom, and let us delete this one as well, and let us delete the chair around this region as well. So let's go CO, enter, and then let's keep this one here. So this is going to be our 15th panel. Okay, go extend. So let's extend this. Okay, so this is very good. This is very good. I can choose to collapse this wall here. Okay, so let's collapse this wall. Okay, so we can choose to collapse this wall. So let's join this down with this. Let us extend. Okay, so this is going to be the 16th panel, CO. Now let's go 16. Okay, so this procedure is actually a very simple procedure. Okay, so this is the same procedure that you are going to use even if you are designing for a larger building. Okay, so you simply need to can simply create your panels in the same way, or perform your general arrangement drawing in the same way. Okay, so that is that. So we now have this panel 15 and then panel 16, and the last one should be our our the last one should be our balcony. Okay, so let us go here and then get this balcony from here. Okay, so let me select this line now and go CO. Okay, so I can choose to go from the base points of the center of that circle over there. Okay, so we can place this here now. Okay, so this is going to be the edge of our balcony. So for that now, I will now choose to delete this. Okay, so we can delete this and have this just like so. Okay, so let's delete. Okay, maybe we can leave this just like so. Okay, so let's just delete the staircase. Okay, so this is what we are going to have for now. Okay, so here is going to be our 17th panel. CO, copy this, place this here. 17th panel. Okay, so this is the area of our 17th panel. Okay, so let us look at that drawing very well. Okay, so it appears there could be a beam holding this panel together. So for that now we need to add a beam to this place. So let us simply offset this by 2 to 5. Okay, so let's select this, then O, enter, and then go 2 to 5, enter. So if you want to learn how to use AutoCAD, so we have done a lot of trainings on that. Okay, so simply visit the REnT customer support to know if you want to learn how to use AutoCAD. So we train you not just in Protastructure, we train on AutoCAD, Aspen High Analysis, Fusion 360, even data analysis, and many much more things that you can be able to do with softwares and designs. Okay, just always feel free to contact REnT, and then we can always guide you through them. Okay, so having done that, now let us delete this first floor label. Okay, so this now is what we now have. Okay, so this is what we are going to be exporting to Protastructure to be our DXF file or the GA drawing. Okay, so after doing this now, this is what we are going to get. Okay, so let us also additionally add this one here, this column here. So remember that this column is going to be starting from the level above. So for that now, I'm just going to copy that column and then let's place it here. Okay, so whenever we see this plan now, we can simply know that this column is going to start from the ground floor and terminate here, and this one is going to start from the floor above. So when we are doing our designs in Protastructure, once we finish creating the first floor, and then when we copy it to the second floor, we can simply come around this place and then delete the column here, and then place another column from this place. Okay, so this is what it's going to look like. So maybe you can leave it at this axis intersection, and it's going to have some eccentricity distance. Okay, so eccentricity distance of 188 millimeters. Okay, since this is going downwards in the x direction, or I mean in the y direction, so that will be the eccentricity distance for this column. Okay, so it can be able to fit on this beam as well. Okay, so moving on from here, we have now, okay, so moving on from here, the next thing we need to do is to now know how we can able to transition this general arrangement drawing to AutoCAD, to Protastructure rather, because all that we have been doing here is all based on how we can be able to use them for designs in Protastructure. Okay, so we have an error here. Okay, so let us correct that error. This grid here is supposed to be at the center points of this beam going to this place. So for that now, I'm just going to move this beam by half of the width of the wall, or half of the width of the beam. Okay, so which is 112.5, since we have a beam width of 225 millimeters. Okay, so it's going to look something like this. So let's select this. Okay, so it can be looking very fine. Okay, so this is what we have for now. Okay, so stay tuned. At the end of this lesson, we're also going to be showing you how you can be able to print your design after you must have finished your detailings. You have finished your analysis and design in Protastructure, and you have now completed your detailings. Okay, so a question was raised: how can we do printing? How can we print our detailed drawings after we have finished that? So at the end of this, I'm also going to show you how you can be able to do that. So this drawing now, or this plan, is what we are going to be exporting to Protastructure. Okay, already I've shown you how to work from here, from something like this now. Okay, and achieving something like this. Okay, so the way you do your general arrangement solely depends on you as a structural engineer. Okay, so if you can see now, this is now arranged in a kind of a frame. Okay, horizontal and vertical members. Okay, so we transition it from something that looked like this now, okay, with all these open spaces and hatches and others, to now look like this now. So from this now, we can now start exporting this to your drawings. Okay, so I always advise you to take a lot of time to do your general arrangement drawing. So because we are restricted by time, this training, that is why I'm going fast. Okay, so I always advise you, even if you can use up to 2 hours to perform your general arrangement drawing, just take out your time and do that, because that is where your design actually begins. If you are going to have a lot of problems doing your modeling and analysis and design, it all begins from your GA, from a very poor general arrangement drawing. So when you start doing a very poor general arrangement drawing, or maybe because you are in a hurry, or you want to submit or you want to meet deadline and all that, okay, and then you do a very rubbish GA drawing, you're going to end up having huge problems in your modeling and designs. Okay, so you find yourself modeling and remodeling, going back to add columns, going back to doing all this. Okay, so just take out your time, make sure that distances between columns are what they should be. Okay, so I want to delete this curtain wall. Okay, so that's actually a curtain wall. Okay, so let's delete this and let us add a proper wall to that. So let's go extend, enter. Let's extend this. Okay, So it's not extending, so let's just drag it. Okay, so let's offset it. Okay, or rather, I just select this one. Okay, let's just drag this one as well. Okay, so this is very good. This is very good for now. So this now is what we are going to be exporting to Protastructure. Okay, so and from here now, there is something that we need to make sure we do, because Protastructure, knowing that Protastructure only recognizes a DXF file. Okay, so we are not going to be exporting the whole of this working space to Protastructure. We are only going to we only need to be exporting only this one to Protastructure. So we are going to do something. Okay, I'm going to show you what you are going to do now in order to be able to export only this as a DXF file. Already this is already this drawing is already been done in the DWG workspace. If I save it now, it's going to save as a DWG drawing. Okay, so let us save. Okay, so whenever you are performing designs, okay, whether in AutoCAD or in Protastructure or anywhere, always form the habit of saving. Okay, so we have not saved for a long time now, so always form the habits of saving, so that if your system runs down or it times out or it goes through and unexpected errors and all that, Protastructure always does that. So you could lose a lot of hours of work. Okay, so always form the habit of saving. Okay, so to do that now, you need to select this, type W block on your command prompt, or just simply type W block. Okay, you're going to see this here, W block, click on it, and then you're going to find this dialog, this right block dialog. Okay, so you're going to be selecting creating this as an object. Okay, just selecting object. Okay, so let's quickly set the units to millimeters, and then let us go here and then check impute a file location where this DXF drawings is going to be saved. Okay, so I want to save it as in my desktop. Okay, so let me just save it over here in my desktop. Okay, so I will just name it, just choose a name, it's just a name. So let's just go REnT let's go DXF file. Okay, so and most importantly, when you, because I've done this a lot of time, that is why it is automatically as DXF. Okay, so when you come here, it's usually as DWG. So always make sure you click on this drop down arrow and then select DXF. You can choose any DXF format. Okay, so let me just go with AutoCAD 2018 DXF and then click save. Okay, so when you come back here, you're going to find this, just simply go OK. Okay, so this is well understood. Again, I am going to repeat that. Okay, so once you are done with your paneling and arrangement, just like so, type W block on your keyboard. Okay, just type W, the W block is going to be there, and then select the W block. Okay, so this screen is going to come out. Already it says already, and we have not selected this. Okay, so if you have not selected, if you have not pre-selected this, just go here where it says select objects or pick points. Okay, I'll simply go with select objects. When you click on it, this window is going to come out, which is going to allow you to select the desired objects. Okay, just select it and then click enter. Okay, so when you click that, you're going to notice this that says 389 objects were selected and all that. Okay, so go here and then change your millimeters, change your unit to inch, from inches to millimeters, and then make sure you choose a file path where you can save file location, where you can save your DXF file. Okay, so I've already done this. I don't want to do this again. I just simply click cancel, then click cancel. Okay, so now having done this, now we can now simply from here go to our Protastructure to now go and import this DXF file that we have already saved, and then let us see how Protastructure is going to read that and how it's going to respond to how you're going to respond to Protastructure software. Okay, so already you have to keep in mind that we created our columns here as polyline elements, and then we created our grid as single line elements and not polylines. Okay, and they are all attached to certain layers, even though these ones are of different colors, but they still belong to the columns layer properties. Okay, yeah. So now let us minimize and then let's go to our Protastructure designs, our Protastructure software rather. Okay. Okay, so let's open up our Protastructure. I've already pre-opened this up before. So when we go to our external reference drawing and then let's click add. Okay, so this has already been done multiple times during our various trainings, okay, on Protastructure. Okay, always feel free to contact the REnT customer support. We have done a lot of trainings on Protastructure. We have done trainings on how to design a five-story building. Okay, during our advanced training sessions, we have done trainings how to design a three-story building, how to use Protastructure from scratch. So if you are a beginner, I will advise you to just check check on YouTube, okay, or visit the REnT customer support, and then you can request to get and watch the videos on our trainings, okay, where we taught Protastructure from beginner levels, how to create grids and all that. So we are not going to be going back to that now. We are simply going to go into what we have for now. Okay, so I saved this my desktop. Okay, so this is the file here, REnT DXF file. Just click on it and then say open. So we are going to give it some time to open. Okay, it says here importing DXF file. Okay. Okay, so it says here importing DXF file. So let us wait for it to finish importing. Usually it takes about 2 minutes at max. It usually takes less than that. Okay, so let us simply wait for them. Okay, so after this now we are going to be showing you how you can print, okay, your detailed drawings. Okay, this is out here. So simply click on active to activate it. Okay, just click on active. You are going to see it in our background. Once it's fully okay, you can notice in our background we are already seeing that here. So let's use the DXF colors and then let's say okay. Okay, so this is what you are going to get. Okay, this is a DXF drawing that we just created, and then you will notice something very disturbing. Our panels or our text become diagonal and kind of larger than it was supposed to be. Okay, so it's not an error, we can deal with that. Okay, so it's just a text, it doesn't really affect your designs. Okay, so now let us go to our external reference drawing and then let us open this up and then import members. Okay, so that you can see how that works as well. Okay, so although we have already done a lot of videos on this, I've done it multiple times. So what I want to import is grid and columns. I didn't model walls. Okay, but it's pretty much the same procedure. Okay, if you modeled shear walls, that is the core of a building, assuming you are designing for a medium-rise building or a high-rise building. Okay, so you might want to model a lift shaft, and it's done as a shear wall. Okay, so you can actually import that using polyline elements, just like so. Okay, so the member we are importing is grids, and we are also importing columns. So the layers that is going to be reading these grids from is the one that we selected when we are doing in AutoCAD as grids. Okay, so automatically the software is very intelligent, it chose that one automatically. And here columns, it's already chose columns, but this, it says A calls. I don't want to use that, so I just turn that off, then leave this one alone, leave only this one. Okay, and then text layer, so we have not done any text, so I might want to turn that off. So let's say okay, so this is what we have imported. Okay, so let's go grids, and then that is that. So just simply click on import and then wait for it for about a minute and a half for it to finish importing. Okay, so after this, now we are now going to go into we are now going to start showing how to do printing. Once you have finished doing your analysis and designs in Protastructure, and you have developed, you have prepared your drawings, okay, your detailed drawings. I am now going to show you what you can do, okay, or how you can print that. It's usually very, very simple. It's just the normal way of printing. Will be converted to grids, 20 lines, and number of polylines that will be converted to columns, 26. Okay, number of circle will be converted, that is our circular columns. Okay, just say close and then say okay. So once you have done that, you are going to notice this. Our columns have been imported, our axes have been imported. You can see on our structure tree, our axes have reported to their respective columns. Okay, so these axis labels we are choosing automatically. So you still have the option to double click and go to the properties and re-label your axis the way you want them to be. Okay, so we have done a lot of videos on that. So let's open up the 3D view so that you can see what we have successfully achieved. Okay. Okay, so this is the 3D view now. Okay, so the columns that we have just modeled in Protastructure, I mean in AutoCAD, we have just created them here. Okay, can you see that now? So it's looking actually very, very exquisite. So if you have been attending our classes or you have been following up, so this should not be a surprise for you. Okay, so you know what to do from here. Okay, how to model your cantilever slabs, all those cantilever I mean slab edges that we have modeled here. Okay, you actually know how you can go about that. Okay, how to add wall loads. Okay, we have done that, and how to add various kinds of loadings. Okay, so that is that now. So this brings us to the end of this okay, so our training on knowing how to perform a general arrangement drawings, okay, in AutoCAD. Okay, so let us open up our AutoCAD again. So the next thing I want to show you is how you can be able to perform your printing, how to print, okay, in AutoCAD. Okay, so we have done that before. Okay, I mean we have not done that before, but I want to do it now. Okay, so there are various ways that you can print your work after you have finished doing your details. Okay, so one of those ways is what I'm going to be showing you now. So for that, now I am going to open a previous work that I have done before. Okay, so this is a building, this is a raft foundation slab detail. Okay, so this is a 3-story building that is sitting on slab raft foundation. Okay, so I have now successfully completed the general arrangement drawing of this, just like I've shown you, and also completed the slab, I mean the modeling, analysis, and design on Protastructure, just like we have always been doing. And now this detailing was also performed in Protastructure. You can see now. Okay, so this is the raft foundation layout. So this is the raft beams. Okay, so you can see our column labels here, and then this is notes that is showing what this is all about. It says all dimensions are in meters, unless otherwise stated, and all this which states the characteristic strength of concrete that we use for these members. Okay, and the characteristic strength of steel, that is the tensile strength of steel, and the compressive strength of concrete that we used for this analysis and design. Okay, and all this. Okay, so this was actually detailed here in Protastructure and all that, although there is a template that you can actually use to make that look better. So just observe the way this drawing is. how neat it is. None of the labels are intersecting with any of the lines. Okay, so you can see the dimensions, and you can see the columns, and you can see here we have the ground beam one. Okay, so we have here ground beam one as well, because both of them are very, very similar. Okay, so we have here ground beam two. Okay, so this is ground beam three, and so on. And this is a different column. We have here, this is column five, this is column three, and over here we have a column one here. Okay, so this was actually done in Protastructure, and here is a section of this slab. Okay, that we have here, section X. Okay, so it actually says section XX. Okay, so this is how it looks. So this is a concrete beam. The toe of this concrete, okay, of this beam here, because when the beam has exceeded 1,000 millimeters, okay, it's no longer seen as a beam at the ground level. It's designed as a wall, okay, as a retaining wall. This beam here at the ground level is designed as a retaining wall. Okay, so this is the toe of the retaining wall per se. Okay, but it was a beam. Okay, so the toe is 850 millimeters of length. This is ground beam, and this is the slab. Thickness is 200 millimeters. So sharp sand will be filled here, and this is a core stone filling before we can be able to pour our concrete directly. Okay, so this is just a section that is showing what we have here, and here is the grout foundation beam details. You can observe the details and see how neat these details are. Okay, so the letters or the labels are not interfering with any of the elements. This is the reinforcement, and this is the detailing of the reinforcement. It says 4T10 at 300. That is for the length, and here it says 3T16 top. TT is top. That is at the top of the that is the top reinforcement of this beam. Okay, so the length of this beam or the depth of this beam is 1,000 millimeters, and the width is 300 millimeters for this beam now. Okay, so this is the detailing of this beam. Okay, so this is the detailing of this web beams. Okay, we have also treated this in Protastructure as well in our trainings. Okay, web beams. Okay, 2 times 3 T16, that is 2, 1, 2, 3, 3 T16 here, then times by 2. That is because it is 2 here. Okay, that is the explanation of that detail. Okay, so we have all this here as well. You have all the beams details. Okay, so this is the slab route foundation slab details. Okay, so this is the detailing of the slab. It's looking very, very neat. None of the elements here are intersecting with each other. So one thing that is very, very important when producing a detailed drawing, because the detailed drawing is the only thing that the builders at the site are going to understand. They don't know all those bending moments and all that. So the only thing that communicates to them is the detailing. So for that, your detailing must be very, very exquisite, very, very clear, and very, very concise. You must not have detailed drawings that are not very, very easy to read. It's going to cause inaccuracies in sight. It's going to lead to errors, and the worst case scenario is it can even lead to collapse of building, and it is just due to poor detailing because they cannot be read. Okay, so this is actually a top. This is okay. Here is a lap length of this bar. Okay, 600 millimeters. That is the minimum lap. Okay, so here is the top length, the top rebar. Okay, the top rebar of this. Okay, so we can follow this call out now to see where we called it out. Okay, it's called out here all the way down here, and all the way, look at this now, showing you that it's called out all the way down here. So it says 17 T12 11 at 175 BB. So this 117 is simply the number of rebars, and T12 is simply the size reinforcement. 12 means millimeters, the diameter of the reinforcement, and T here simply means the bar designation for higher strength according to the British standards. And here 11 here is just the bar mark number, and 175 here is the distance, center to center distances of the reinforcement, and the B here simply tells you the layer which the reinforcement is going to place at, which means bottom, and T here is top. Okay, so this is rough foundation details, and this is notes, and this now is a section, okay, showing the reinforcement arrangement. You can see now this reinforcement went all the way from here now, okay, for the slab, okay, and then for this beam now, you can see the way these reinforcements are arranged. Okay, you can see it now. So this is very, very, very good. Okay, this one as well. Okay, so this is the first, second, and third floor slab, beam, and column layout or arrangement. Layout or arrangement, that's something. Okay, so this is because we have the first, second, and third floor are typical. Okay, are similar. They say, okay, that is why we have this label just like so. Okay, so this is the arrangement. This is where the column, this is the beams, and these are the grid lines. Okay, so the grid lines here are labeled, and the distances between the grid lines, because this is a detailed drawings, and this is the first, second, and third floor beam details. Okay, so these are the beam details, and this is slab details for that as well. This is a void, which is a staircase region, and all that, and it continues the roof beams, and then the column details. The column details are not here. Okay, so the column details was removed. Okay, so the column details are not here. So now let us go to the reason why we came here. So we came here so that I'll be able to show you how you can be able to print. So there are actually many ways to print in your design. Okay, one of those ways is using this printing layout option here. Okay, so you can just simply take it here and put it here, but this is going to take us a lot of time to explain. Okay, so I'm going to use the most simple way of printing your work in AutoCAD to explain that. Okay, so for that, now I will just simply go to print, this option that says here print or plots rather. Just simply click on it once, and then let's just go continue single plot. Okay, so you can do all your basic settings here. Microsoft AutoCAD to PDF. You can choose your quality that you want, and then you can choose your paper size. It's usually A3, isometric A3, so I prefer 420 to 97. Okay, so it will be in landscape mode. Okay, so go here and then select Windows. When you select Windows, this dialog is going to appear, that is going to allow you to copy or to draw a screen over the region you want to print. So if I want to print this foundation beam details, okay, I can just simply click from here, from this endpoint, and go all the way down, to this place. Okay, so and then just simply click it. So when you have clicked that, you're going to get something that looks like this. Okay, you're going to get back to the dialog. So click on preview and let us see what you have selected, what it's going to look like on sheet. So this is what it's going to look like on sheet. It's actually in black and white. Okay, so just click that to take that off. Okay, and then we are back here. Then here you get the option to change the quality. Okay, it was in AutoCAD AutoCAD.ctb. You can change it to monochrome, DWF styles, and all that. If you want it to be colored, you can change it there. And the quality, you can check the quality you want. So I just leave it as normal. You can choose a higher quality if you want. Okay, so and all these settings, you simply just need to look at it. They are very well, they are actually self-explanatory. So anyone you click on plot in background and all that, just simply come to preview and then click there to see what it will look like. So once you have finished doing that, just click on OK. So this screen is going to prompt you to specify a file, a location to save this file. Okay, just go desktop for now. and then let's call it A. Just call it A, then save it. Okay, so it is now being generated as a PDF. Okay, it's now being printed as a PDF. Okay, so that is just the simple way of printing your work. Okay, so you can now start dropping your questions. Okay, just type on the chat box now. Okay, so that I can start reading and reviewing your questions. We are already behind schedule. Okay, you're already behind schedule. Okay, so this is what we have now. Okay, for that one that we just printed. Okay, let's just go down and then go here, plot again. If you want to print another screen, just go here, plot, continue, and then come to this side now, and then go to previous plots so that you can be able to know what you have printed previously. Okay, then come here so that all the settings are going to apply. Okay, so come here where it says preview. Okay, what you are going to be seeing is the previous one that we just printed. Okay, because that is the window that was selected. Okay, so go here to window, just click on this window. This will give you the chance to select a new window. So you can see this now. This is showing you that this is what was previously selected. Okay, so you can now move to select this one. Okay, or okay, let us select another screen. Okay, let's simply select okay, let's select this. Okay, so you are going to repeat the same process all the way down for all the files or all the select label this one as B for all the drawings that you have all printed. So usually you are meant to create a sheet that's going to show the details of that your drawing, like designed by who, the client that owns it, the approval, and the person who checked and approved it, and all that. You are going to create a sheet and then place all your drawings inside that sheet. Okay, that's how it's meant to be. Okay, then you can now start cropping. I can now start drawing your screen to print it. Okay.
Can you hear me, sir?
Yeah, I can hear you.
Okay, okay. You have done justice to that, and
Okay, so okay, so okay, so that's after that now you need to just go to your file location and then download this software for um this software called PDF Merger. So you are going to use that PDF Merger to merge your drawings. Okay, to merge these PDFs that you have now created, because they will be in single file, in single PDF files. Okay, so you can just merge them for all of them to be in one single PDF file. Okay, so having said that now, this brings us to the end of our Protastructure lesson. Okay, or to this lesson. Okay, so I'm going to be handing over um to REnT. Okay, so that you can continue from here. So this design was done specifically for this training this evening. Okay, it was done with Revit. Okay, so we are still looking at beginning a Revit tutorial. Okay, in the future. Okay, so we are still working on that. So during Revit, we are going to show you the ins and outs of Revit and how you can use Revit to produce models um, that are in fact better than this one, because this drawing is just for this design. Okay, it's just for this lesson's sake. Okay, so you can produce better drawings that can be used to produce real life projects that are creative using Revit. Okay, so Revit is actually a very tool that any architectural design wants to focus on. Okay, so I want to see questions. Okay, So I'll be looking at the comments section to know if I can find questions.
Okay, so can you hear?
Yes, I can hear you.
Okay, while we wait for their question, and we are going to devote like 3 minutes to that. But so far, what you have explained is self-explanatory. It's something that anyone who started following your session from the beginning up to this point is going to catch up. But if you don't know how to use AutoCAD, you don't know how to use Protastructure, there is a contact, REnT customer support contact I drop in the comment section. I would like you to chat the number up that you want to enroll for Protastructure training, and you'll be added. You'll be given the necessary information for that. Also, if you want to learn AutoCAD also, you contact that number. And just like he said, he was talking about Revit, whichever architectural software or civil engineering software you want to learn, please reach out to REnT customer support or reach out to any of the admin in the WhatsApp group that was created for this training. Okay. I don't know. Have you seen any question in the comment section that needs to be answered? We need to wrap this up quickly.
Okay, yeah. I am seeing a question. The column is positioned inside the living room. Will that not affect the architectural plan, sir? Definitely yes. So the column here that I position, yeah, I think around this region is definitely affecting the architectural plan. Okay. So but it's for safety reasons. Okay. So during design, there are certain factors you need to consider first. So the first factor of consideration is safety. Then secondly, is serviceability, then economy, and then aesthetics. Okay, aesthetics is where the architectural these things belongs to. Okay, some choose to prioritize aesthetics to economy and all that, but nevertheless, safety can always be number one criteria to consider. Okay, so mind you that the length of this beam now, if we are to remove this column now, the length of this beam is going to be going all the way up to 7338 meters. A beam of 7338 meters is possible to be built. Okay, it's not an impossibility. Okay, so but then this beam, from my experience, a beam this length, that is a long span beam, usually fail by deflection and not basically bending, even if the beam is strong and the depth is big. Okay, it's usually fails by deflection. Okay, so one of the ways of correcting a long span beam, the deflection failure, is by increasing the depth. Okay, so when you are increasing the depth, you are going to notice the depth is going to be dropping up to 600 millimeters or 700 millimeters in order to be able to in order for the beam to be able to stand. Okay, so now looking at this drawing now, we have a height above ground of 3375 millimeters. And when you drop a beam up to 600 millimeters, it is going to still affect the architectural view of the whole open space that was here. I don't know if you are getting what I'm saying. Okay, so the beam is going to still drop deep. So it's now going to be left for you and the architect to now find a way to go through that. And moreover, if you don't add a column here and you span a beam all the way from here to here, it's going to add a lot of weight on this column, causing this column to require bigger section size. Okay, I've already said that the way you do your general arrangement and design depends solely on you as the structural designer or structural engineer. You can choose to remove this column, or you can choose to add it or leave it like this. Okay, but this way is the most suitable way that I can be able to have this here. Okay, so let me show you something about this column. Okay, let's copy this down. So let me go all the way.
This class was supposed to end by 9:55. This is 9 already. So whichever question
I will
you
wrap
have, you
up
can drop.
Okay, I will wrap up the class
Okay,
in 2 minutes.
while you are wrapping up, those of them that still have more questions, please drop it in the WhatsApp group. I think the WhatsApp group is open. And this is a one-day class to introduce you guys to how to navigate from AutoCAD to Protastructure back and forth. It's not a comprehensive class, so there are some things we can't cover in this training. You get. So if you want to know more, this is where you now make payment for the advanced session, where you take time to break this thing down into bits and pieces for you to understand. Okay, so you just have 3 minutes remaining. This is 9:57. We need to end this class exactly 10 o'clock. Thank you.
Okay, so that should be that. Okay, he has answered most of the question. Most of the things that we are asking can be dropped on the group chat. Okay, so moving on now. I saw another question that says sheets to print in source like the name of the design. Okay, that's what I was explaining. So you can just create a sheet, okay, a rectangular sheet, and write your names um and just create the sheets, the normal way of creating sheets. Okay, so and then just insert your drawings into them and print that. Okay, so it was asked by David. So David can always chat me. Okay, so I will just explain through more like that. So the cantilever that is up to 1.8 meters, will it stand without a beam? So this cantilever slab of up to 1.8 meters, it's always possible to stand without a beam. That is why that is why now we have what is called overlapping length. Okay, so when you put a reinforcement here, the reinforcement has to lap all the way back down. Okay, so that is what the demand is right now. Although it's going to be very very expensive, but then it is also still possible. Okay, so when you parcel exceeds 3,000 meters squared, 30 meters squared, the beam you add at center, the beam you run at the center, is it a depth or is it a hidden beam? So it's going to be a depth beam. Okay, it's not going to be the same depth with the depth of the slab, because what you mean by hidden beam is a slab beam. Okay, that beam that you run inside the slab. Okay, so it's going to depth, it has to depth. Okay, so it's not going to be the same thickness with the slab thickness. Okay, I believe that has done justice to the question. Always feel free to chat us on the WhatsApp. So we have the WhatsApp group. Okay, reach out to the REnT customer support, and most of the questions that you are going to be asking, always feel free to contact me or the REnT customer support. We can always answer your questions at any time. Okay, this has been a very wonderful class. I really enjoyed this and I enjoyed your company. Thank you very much for being here and staying all up to the end of this training by this time. Okay, I really appreciate you guys. Thank you very much and have a wonderful evening and a wonderful night rest. Happy Valentine's Day, you. Thank you.
Yeah, thank you all for participating in today's class. For those of you, like I said previously, for those of you who want to go further into learning Protastructure and for structural design and modeling, AutoCAD for structural detailing, please reach out to the number in the course in the chat box, the chat section, or reach out to any of the admin in the group chat. Thank you once again and good night.